To solve a triangle means to find the measures of all the angles and all the sides of the triangle. Hello, my name is Tom Atwater, and in this section we will solve application problems using triangles. In solving a triangle, a labeled sketch is an important aid, like the triangle seen here. We have that side A represents the side opposite angle A. We have that side B represents the side opposite angle B, and side C represents the side opposite angle C. And when it's a right triangle as pictured here, C always represents the hypotenuse. All right, well, let's do an example where we find the sides and angles of a triangle. So what we have is a triangle in which we are given that angle B is 42.0892 degrees, and side B, which of course is the side opposite angle B, is equal to 56 and 851 thousandths centimeters. Okay, let me draw that triangle on the board so that we can work with it. So it's a right triangle, and we know that this angle is 42.0892 degrees. And we know that the side is 56.851. And this was B. Of course, we know that's C. This is angle A, so that's side A. And this would be angle C, which we already know is, of course, 90 degrees. So we can use the right triangle trig to find, for example, side A, because we know that opposite the angle 42 is the 56.851, and the side adjacent is A, so therefore the tangent of 42.0892 degrees is equal to the side opposite divided by the side adjacent. And therefore the side adjacent, which is A, is equal to 56.581 divided by the tangent of 42.0892 degrees. Well, let's hop onto the calculator and calculate what that works out to be. So what we want to do is actually take 56.851 and divide that by the tangent of 42.0892 degrees, which I have it in degree mode, and then I press enter. And what we'll find is that that side A is approximately 62 and 94 100ths centimeters, which is what originally we had. Okay, well, now let's go and find side C, which is the hypotenuse. And to do that, we can use either sine or cosine. So I'm going to start off with the sine. We have the sine of 42.0892 degrees is equal to the side opposite, which is 56 and 851 thousandths, over the hypotenuse, which is C. Therefore, C is equal to 56.581 divided by the sine of 42.0892 degrees. Once again, let's hop onto the calculator and plug that in to find our answer. So what I take is the side of 56.851, and I divide that by the sine of 42.0892, and I get that it's approximately 84 and 816 centimeters. And I, of course, rounded that off to the 3 decimal points as we did, or as we were given the original problem. Now, the only other missing part that we have here would be angle A. But we know that angle A and angle B, the given angle, are complementary. That is, they add up to 90 degrees. So all I need to do is just go directly to my calculator, and what I can do is type in 90 minus the 42.0892. Hit my enter key, and it works out to 47.9108 degrees. So I found all of the missing parts for the triangle that I was given in the original problem. Now, many applications of right triangles involve angles or of elevation or angles of depression. And here's the angle of elevation. It is the angle created between the horizontal, which is this line here, and what's called the line of sight. And by the line of sight, we mean here's the person observing, and they're looking from here, and they're looking up at some object that's above them. And that's why it's called angle of elevation, because the object they're looking at is above. Well, now let's take a look at the angle of depression. The angle of depression is, again, the angle between the horizontal, and this time the line of sight is below the person. Here's the person, and here's the object. And what you'll notice is that the object is below them. So the angle of depression is downwards. And the angle of elevation, of course, is upwards. Now, there is a caution that I'd like to show you. I want to caution you because you need to be careful when interpreting the angle of depression, because both the angle of elevation and angle of depression are measured between the line of sight and a horizontal line. Angle of depression would be looking down, angle of elevation is looking up. Now, here's an exercise where the angle of elevation is used to find an unknown quantity. Suppose the elevation of the sun is 23.4 degrees. Find the length of the shadow cast by Diane Carr, who is 5.75 feet tall. A sketch of this will be very helpful. So let's take a look at a drawing from the book that shows Diane Carr along with the sun. Diane, of course, is the 5.75 feet tall. The angle of elevation up to the sun from the ground, that is to say, you can see that we've cast her shadow right along here, and the angle of elevation is 23.4 degrees. And what we're interested in finding is this length, x, the length of her shadow. So, to find the length of her shadow, let me redraw that picture, but just use that section that shows Diane Carr, who's 5.75 feet tall. X, of course, is her shadow. We know this is a right angle, and this is 23.4 degrees. Therefore, to find x in this, we can use the fact that the tangent of 23.4 degrees is equal to the side opposite, 5.75, divided by x. So, tangent of 23.4 degrees equals 5.75 over x. Therefore, x is equal to 5.75 divided by the tangent of 23.4 degrees. Let's go to the calculator and plug in those values and calculate the length of her shadow. So I would want to plug in then 5.75 and divide that by the tangent of 23.4. Hit enter and we'll find that her shadow is approximately 13 3/10 feet. Other applications of right triangles involve bearing, an important idea in navigation. One method for expressing bearing starts with a north-south line and uses an acute angle to show the direction either east or west of this line. In the example on the left, we have north 42 degrees east. So we start on the north line and we rotate 42 degrees towards the easterly direction. In the second example on the right, we have south 31 degrees east. So this time we start on the southern line and we move 31 degrees towards the east. In my next example, I have south 40 degrees west, and that's on the left-hand side. And on the right-hand side, I have north 52 degrees west. Let's do an exercise using this method of bearing. We have a ship leaving port and sailing on a bearing of north 28 degrees, 10 minutes east. Another ship leaves the same port at the same time and sails on a bearing of south 61 degrees, 50 minutes east. If the first ship sails at 24 miles per hour and the second at 28 miles per hour, find the distance x between the two ships after 4 hours. First, let's find the angle between the two ships' paths. So in the diagram, we see that the three angles, including the angle between the ship, which I'm labeling with this red arc, we know that all three angles, which I now label the other two with the red arc, must add up to 180 degrees because they form this total angle right here. Well, we already have two of them, so basically what I want to do is take 180 and then subtract from that the sum of the other two angles, 28 degrees, 10 minutes, and plus the 61 degrees, 50 minutes. Now, interestingly enough, if you are familiar with the degree and minute, and possibly, but not in this case, second measure, you could just add those angles as is. The other way would be to convert them to decimals on your calculator and then have the calculator do it. However, looking ahead in this problem, I know, because I've worked it out, that those angles actually add up to 90 degrees. And I want to show you that using the degree and minute version of it. So let's go back to the diagram, and I'll show you that if I add 10 minutes plus 50 minutes, that's 60 minutes. And 60 minutes makes a full degree. So what I would have is 28 plus 61 plus 1 degree, which adds up to 90. And therefore, what I find is that the angle between the two ships is 180 minus 90, or in other words, 90 degrees. So therefore, this angle in here is a right angle, and I therefore am dealing with a right triangle. So now what I'm going to do is move to the board where I will draw essentially this diagram as a right triangle and then fill in some more information. So what I have is the two ships. This is a right angle here. And what I know is that this ship is traveling at 24 miles per hour for 4 hours, or in other words, it travels 96 miles. Now, the second ship also travels for 4 hours, but it's traveling at 28 miles per hour. So that means 28 times 4 for 112 miles. What we're interested in is this distance right here, which I will label x. In order to find that x, let me first find angle theta, the angle up in here. What I use is the tangent function to say tangent of theta is equal to the side opposite theta over the side adjacent to theta. So now I know that to find theta, theta is the inverse tan of 112 divided by 96. So let's jump onto the calculator, plug in inverse tan of 112 over 96 to find theta. So we have inverse tan, you have to push second tan, and that gives me the tan inverse function. Then I plug in the 112 divided by 96, close the parentheses, hit enter, and I see that my angle is approximately 49.3988, for example. All right, well, now that I have that angle, I can use either the sine or cosine function to find the hypotenuse. So let me show you that. This angle theta turned out to be 49 let me look on that calculator again, 0.3988. So therefore, the sine of that angle is equal to the side opposite, 112, over the hypotenuse, which I've labeled as x, which means x is equal to 112 divided by the sine of 49.3988. All right, let's move to the calculator, and we can solve for x, the distance between the two ships. So what's good about the calculator is I still have the 49.3987 in there. So what I'm going to do is say that I want 112 divided by the sine, and then I can plug in second answer function. So second answer, close the parentheses, and it's going to plug in my 49.3987, etc., and hit return, and it comes up to 147.51. In other words, we could basically just round that off and call it 148 miles that the two ships are apart after 4 hours at sea. Well, now I would like to give you the opportunity to solve a problem involving bearings on your own. A ship travels 50 kilometers on a bearing of 27 degrees and then travels on a bearing of 117 degrees for 140 kilometers. Find the distance x between the starting point and the ending point. Now, pause the video while you work on this problem, and when you've finished, restart the video to check your solution. All right, let's find out how you did on this problem. I have a book diagram that I want to start off by showing you, and then we'll transfer that to the board. So here we have the ship, which originally starts off on its bearing of 117 degrees. And we have the other bearing of 27 degrees, and we have the two distances of 50 kilometers and 140 kilometers. We're interested again in x, the distance that the ship is actually from the port after dealing with those two bearings and distances. And before I move to the board, what I want to show you is that this angle inside the triangle is in fact a right angle. And the reason we know that is we transfer this bearing of 27 degrees up to here. And what that tells me then is that this angle inside here with the double arc would be 117 degrees minus 27 degrees, which gives me 90 degrees. And of course, if that's 90 degrees here, then this one also has to be 90 degrees. So now what I can do is take that information that I'm dealing with a right triangle again, and then put it onto the green board, and we can continue with that problem. Okay, so my triangle looks like this, where I have a right angle. I know that this is equal to 50, and this is equal to 140. I'm interested in angle X. So once again, if I choose one of these angles to call it theta, then I can use the tangent of theta is equal to the opposite over the adjacent. So tan theta is the opposite over the adjacent, which of course I can reduce to 5/14. Now on the calculator, we can figure out that theta is going to be the tan inverse of 5/14. So let me do that right now on the calculator, where we will type in second tan, which gives me tan inverse, and then 5 divided by 14, close the parentheses, and hit enter. And what I come up with is 19.6538, etc. degrees. So now I can take that and, for instance, use either the sine or cosine to find the hypotenuse x. So let's set that one up right now. I can take, and this time let me use cosine since last time I used sine. So the cosine of that angle theta, which I'll leave as theta for the moment, is going to be the adjacent side over the hypotenuse. And that means the hypotenuse is equal to 140 over the cosine of theta. But of course, theta we have in our calculator, so let's move over and calculate this. So I want to say that it's 140 divided by the cosine, and I want to take my answer of 19.65, so I do second answer, close the parentheses, hit enter, and that works out to 148.66, etc. Now, again, since the lengths that we're dealing with so far are whole numbers, we will approximate this as the whole number of 149 kilometers. Okay, great work in today's lesson. We've only been able to touch on a few of the application problems presented in this section. To improve your proficiency in solving right triangle problems, be sure to work the exercises that your teacher assigns, and we'll see you next time.